At Aerzen, since 1864, we design high-performance blowers, screw compressors, and high-speed turbo blowers for the industry. We introduced Europe's first positive displacement blower back in 1868. Since then, we have become a global player with over 50 subsidiaries around the world and more than 2,500 employees. Our goal is to redefine quality and innovation, so when you see an Aerzen name on a machine, you know exactly what you can get. You can expect performance. Hello, I am David Salazar, Aerzen Regional Application Manager for Pneumatic Conveying Applications. Welcome to this interactive presentation, which is meant for you and me to participate and learn from some real case scenarios related to energy, CO2, and cost reductions in the pyro processing for cement manufacturing. We're glad you've decided to join us in today's presentation. If you are willing to learn more about other applications or Aerzen services for the cement industry, you can also take a look to our specific application content in our YouTube channel. Successful operation of a rotary kiln in cement plants require an adequate source of heat that will first raise the kiln to the operating temperature of over 1400 degrees Celsius and will then maintain that temperature by compensating for the various heat losses occurring in the kiln system. The heat is obtained by the combustion of fuel, mainly coal, combined with oxygen in the air. To obtain a proper combustion, two requirements must be fulfilled. First, sufficient oxygen present into the mix with the fuel, and second, a constant and stable fuel supply into the system. Primary air, jet air, or combustion air, depending the region where you are, all terms means the same. Air supply for the primary burner in order to guarantee a proper combustion with a beautiful long and wide flame across the kiln that guarantee the most heat transfer into the kiln. Many variables are involved into selecting the proper equipment to deliver this air into the system, but there is one that definitely matters the most for the production process. Which one do you think is the most relevant variable? If you select option C, you are correct. Momentum or mass flow is the most critical variable as it defines the oxygen mass flow that will be delivered into the system to guarantee the proper combustion. Ambient variables such as altitude over sea level or ambient temperature can dramatically affect the momentum and in consequence the heat transfer into the kiln. In addition to this, combustion air is the only resource for cement plant operators to control the kiln temperature and adjust it when a bad quality batch of raw materials enter the kiln or a new fuel usage is required. Aerzen has been really successful to supply high quality advisory and reliable machines into this application, to the point that some of the major cement companies at a global level prefer Aerzen equipment for this specific application. In our customer cement plant, the situation was critical, as the existing blowers for the process were very close to their operational limit. Considering the burner replacement and additional production capacity, the volume flow variable range was very limited. Existing machines didn't have variable speed devices, and they were thinking to upgrade the blowers to a bigger size with more capacity. Aerzen engineers analyzed the situation and realized that the high-speed turbo technology was a perfect fit for the expected operational condition. Technical data is as follows. The challenge in this case was related to increase the mass flow through the same pipe system from 5,350 kilograms per hour to 6,800 kilograms per hour of air. In this case, the application is also known as process air, basically because there's no pneumatic conveying of any material through the pipes. Only air is conveyed to feed the kiln. But if there's no material handled through the pipe, how is the differential pressure generated in the system? Answers goes back to the continuity equation, where the pipe diameter reduction at the end of the pipeline increases speed and air turbulence to generate additional momentum and helps the combustion process. In this case, the most critical limit was given by the pipe diameter. We did want to increase mass flow and turbulence into the system, but having too much air through that pipe diameter could also choke the air output due to extreme turbulence. With the on-site conditions, the best possible options was to install a high-speed turbo blower, which gives a constant mass flow through a high-speed impeller, giving to the process reliability and the additional mass flow needed according to the pipe diameter. In addition to this benefit, Aerzen Turbo includes an unbranded variable speed device that helps control the system and the airflow in case of alternative fuel or a raw mixed material change entering to the kiln. This application helps the operator to control the process, same way you control oxygen supply when using a torch. Let's review the key takeaways from this case scenario where we replace a delta blower with the high-speed turbo technology. First, air speed increased with a variable speed device, which creates additional turbulence in the mass flow delivered, making the flame size bigger and robust. Second, footprint reduced compared to the previous technology, and maintenance costs reduced to almost zero as turbo technology is maintenance-free. Third, electrical energy consumption dropped by 30% compared to previous technology, and additional control of the process to handle different raw material batches and new alternative fuels. Thanks for joining us today in our interactive presentation. We hope you have enjoyed our journey through one of the most exciting processes in the cement manufacturing. If you have any further questions, I'll be happy to discuss it with you later. And make sure to contact your Aerzen entity in your region for any specific questions or local support you need from our team. Thank you.
Expect performance.
Expect performance.
Expect performance.